Okay, so we're on part 2 of compositions of functions. And what we learned from the last video, that a composition of functions, a definition, given two functions f of g is also a function called the composition of f and g, or f composed with g, or f of g. This is the most common use here, f of g. And it's defined by f of g, or f of g of x, or f of g of x. Lots of different ways of doing it. And here was our graph that shows x turns into g of x, which turns into f of g of x, or I can go straight with this fancy function f of g. Let's do some examples here. Fill in the following table. Here is my function f and my function g. X, I'm going to find g of x is 1. I do 1 squared gives me 1. If I do 2, I plug 2 in, I get 4. I plug 3 in for g. I plug 3 in here, 3 in there, and I get 9. Similarly, I get 16 and 25. And then I want to do f of g of x. Well, when I do that, I take 1 and I plug it in to here and here. So 3 times 1 is 3 minus 1 is 2. And then I go and I plug in 4. So f of 4 is 3 times 4 minus 1. 12 minus 1 is 11. If I consider when x was 3, g turned into 9, and f at 9, 3 times 9 is 27, minus 1 is 26. And if I'm going to do f of g of 1, I'm going to do x is 4, g of x is 16. So f of g of 16, 3 times 16 I know is 48, minus 1 I get 47. And finally I do x is 5, g of x is 25, so f at 25 is 3 times 25, which is 75 minus 1, which is 74. And this is the function f of g of x, because for our last one, I want f of g of 5, which was f of 25, which is 74. So if I want to find an equation then, my equation, I take f and I plug in my g of x, which I know my g of x is x squared. X squared goes in to my function f now. So it's 3. This goes in for my x minus 1, which simplifies altogether just to 3x squared minus 1. And this is f of g of x. This second example, I want you to fill in yourself. Give it a try. It's doing g of f of x. It's switching them around. It's backwards. Try that. I'll be checking. Actually, you should pause the video now, try it, and then you can check your answers. And now that you're back, you can check your answers. It should look like this. Let's try the next example. Here's f and here is g. We want to find f of g of x. So I want f. I'll make g in red, g of x, which means I'm going to go f of 5x minus 2. And now that's going to go into my f, which is 4. Plug in my g into the x value. plus 2, which is 20x minus 8 plus 2, which is 20x minus 6. Try this one. Pause the video and try that one. That's right, pause. Okay, so here's the answer. One thing I do want to point out is here is g of f of x, and here is f of g of x. They are not equal, and that is typical. They are not the same thing, so it depends upon which way you plug your values in. Be very careful. All right, and then finally, we're going to do f of g. Well, that means f of x here, which is f. Well, f is 4x plus 2. And then I'm going to take this value here and plug it in for f into itself. So that's 4 times 4x plus 2 plus 2, which gives me 16x plus 8 plus 2, which is 16x plus 10. Let's try another example. We have g of f of x. Based upon what we've done, I'd like you to pause the video now and give this one a try. That's right, pause. Pause. Okay, we're back. So this is what you should have done. You plug in x plus 3, crunch it out, and there's your final answer. All right, now let's look at h of g of x. So h of g is x squared minus 1, which is this value is going to go in for x in my h. So that's going to be the square root of x squared minus 1. That's my whole entire x plus 1, which is then the square root of x squared. Since I can clearly see those subtract away, square root of x squared is equal to x. And that is our h of x. This is a special scenario. When this happens, these two functions are called inverses of each other. And that's foreshadowing what's coming up next lesson. Let's try another example. These ones I think are fun. So I have my table here. F at 2, it gives me 0. So that's g at 0. 0 for g produces a 10. So my input was 2. My final output is 10. Going to the next one, I'll switch to blue. We'll do f at g at 4 is 2. F at 2 is 0. Okay, try this one on your own. So pause it. So hopefully you got 6. And finally, g at 5. Well, g at 5 produces 0. So I'm going to do g at 0. 0 produces 10. So my input is 5, my output is 10. One more example to consider. Here's another representation of a function. Here is f is the graph, and h is my function. I'm going to do f of h of negative 1. So f at minus 1, if I look at my graph, I go from negative 1, and I see that that is 4. So this is saying h at 4. I plug 4 in here, and it's 3 times 4 is 12, minus 1 is 11. Okay, let's try the next one. The next one says f at 4. Well, f at 4 is 0. So then it's h at 0, which I plug 0 in here. It's 3 times 0 minus 1, which is minus 1, negative 1. And then this one is f of h of 1, which means 1 goes into here. So it's f at 3 times 1 minus 1, This is a 1 here, which is f at, well, 3 minus 1 is 2. 2 produces -8. Okay, so in doing composition of functions, we can use graphs, we can use equations, and we can use tables, and any combination of those, because they all represent different kinds of functions. There you go. Composition of functions, important idea